Welcome to MRL. In this learning session, we will learn the solutions of the examples of the second exercises of the 10th CBSE real numbers chapter, that is the first chapter of 10th CBSE. Now the first question asked here is to prove that root 5 is irrational. That means we are given root 5, we have to prove that it is an irrational number. Now there are different methods of proving the root 5 is irrational, and the first method is now find out the decimal expansion of root 5 by long division method of finding the square root. You should know the method of finding the square root of non-perfect squares, which you already learnt in I think in 8th standard 8th CBSE class. If you have a doubt in finding out the square root of non-perfect squares, you can go through the video on square roots and squares, which is uploaded and is present in my channel. Learn that first. Now here I have found out root 5 by long division, and the value is 2.236067, and it is unending. That means it is a non-terminating, non-recurring decimal expansion, and you all know that when the decimal expansion is non-terminating and non-recurring decimal expansion, then it is definitely an irrational number. Therefore we say that root 5 is an irrational number. So therefore after finding out the square root of 5 by long division method, the decimal expansion obtained is a non-terminating and a non-repeating decimal expansion, and therefore root 5 is 100% an irrational number. And this is one simple direct method of declaring or saying that root 5 is an irrational number. But there is another method, and that method was proposed by Hippasus, and the method is called as a contradiction method, which is a logical method. Now the question is, what is this contradiction method? Contradiction method means assuming something to be true, proving that what we have assumed is not true but it is incorrect, and therefore what we have not assumed is correct. So let us understand this method. Now let us assume first that root 5 is a rational number. So if root 5 is a rational number, then root 5 can be written as a by b, where a and b are definitely co-primes. Remember, a and b are co-primes here. Always remember, when root 5 is expressed as a rational number p by q, you have to cancel out or remove the common factors of p and q. You will get a and b, which are co-primes, and you know that. Now the common factor of a and b is 1. Because a and b are co-primes, the common factor of a and b is definitely 1. So that is my first statement. Now what we do, take root 5 upon ab and cross multiply it. It becomes root 5b is equal to a. Square it. It will get root 5b whole raised to square is equal to a square, or 5b square is equal to a square. Now it is very clear that a square is divided by 5, or 5 is a factor of a square. If 5 is a factor of a square, then definitely 5 is also a factor of a. Now once 5 is a factor of a, it is possible that any multiple of 5 is a factor of a. Therefore let us take a as 5c. Now put a as 5c in this, that is 5b square is equal to a square. We get 5b square is equal to 5c whole raised to square, or 5b square is equal to 25c square. 5 cancels here, we get b square is equal to 5c square. That means b square is divisible by 5, or 5 is a factor of b square. If 5 is a factor of b square, 5 is also a factor of b. That is statement number 3. Now from statement number 2 and statement number 3, what we observe is that a and b also have a common factor as 5. But this contradicts the statement number 1, that a and b have a common factor as only 1 is a common factor. But that means it is contradiction, and this contradiction has arisen. Please understand here, this contradiction has arisen because of incorrect assumption that root 5 is rational. So the conclusion is that root 5 is not rational but an irrational number. So that is how we prove that root 5 is irrational, by contradiction method, and that is what is the logical way of explaining it. Now the second example is to prove that 3 plus 2 root 5 is irrational. Again we can very well say directly 3 is a rational number, 2 is a rational number, root 5 is irrational number. When we multiply 2 into root 5, we get an irrational number. When I add an irrational number to a rational number, again it is an irrational number, because we know that the sum of a rational and irrational number is an irrational number. Therefore 3 plus 2 root 5 is 100% an irrational number. That is the direct method. But by contradiction method, the method, let us understand that. Let 3 plus 2 root 5 be a rational number. So let us assume that it is a rational number first. let us assume that it is a Rational number. If it is a Rational number, then 3 plus 2 root 5 is equal to a upon b, where a and b are co-primes. Now cross multiplying, then what I will do here, I will take 3 to the right side, that is 2 root 5 is equal to a by b minus 3. Simplify it will be a minus 3 by 3b by b. That means a is an integer, b is an integer, again b is an integer, the numerator is an integer, the denominator is an integer, and the whole thing is nothing but a Rational number. That means on the right side, a minus 3 by 3b by 2b is a Rational number, But we already know that root 5 is irrational. So how it is possible that an irrational number is equal to a rational number? That is impossible. Therefore, that contradicts that root 5 is irrational. So root 5 being rational is 100% a contradiction, because root 5 is an irrational, and therefore that contradiction has arisen because of our incorrect assumption that 3 plus 2 root 5 is rational. So the conclusion is that 3 plus 2 root 5 is not rational but an irrational number. Please remember that. Again here, third example, we have to prove that 1 by root 2 is irrational. 1 by root 2 is irrational. Now if I simplify that, and that means rationalize this, I get 1 by root 2 into root 2 by root 2, we will get root 2 by 2, that is half into root 2. But you know that the product of a rational number and irrational number is irrational, and by direct method we can prove that 1 by root 2 is irrational. Again, to prove it by contradiction method, so let us take that 1 by root 2 is a rational. So let us assume that 1 by root 2 is a rational number. If 1 by root 2 is rational, then 1 by root 2 is equal to a by b. That means root 2, please take the reciprocal of this, that means root 2 is equal to b by a, and b by a, b is integer, a is integer, therefore b by a is a rational number, but root 2 is irrational number. So root 2 is irrational, b by a is rational, irrational becoming equal to rational, it is impossible, and that contradiction has arisen because we have assumed that root 2 is rational, and therefore that assumption is wrong. The correct conclusion is that 1 by root 2 is not a rational number but an irrational number, and that is the proof of that. Okay, so please remember that. So the conclusion is very important, that 1 by root 2 is an irrational number. Please remember that. Okay, now to prove that 7 root 5 is irrational, very simple again, 7 is rational, root 5 is irrational, product of a rational and irrational is 100% irrational, so that is a direct method. But we again can prove this by what you call it as contradiction method. So let us assume that 7 root 5 is a rational number. If 7 root 5 is rational, then 7 root 5 is equal to a upon b, where a and b are co-primes. Now bringing the 7 down becomes division, so root 5 is equal to a upon 7b. Now a is an integer, b is an integer, 7 integer, therefore the numerator is an integer, the denominator is an integer, it is of the form p by q, and therefore a upon 7b is a rational number. But root 5 is irrational. So irrational becoming rational, which is impossible. So this contradiction again has arisen because of our wrong assumption, our incorrect assumption, and therefore 7 root 5 is not rational but irrational. So please remember that. Now the next example is to prove that 6 plus root 2 is irrational. As we already know that sum of a rational and irrational is irrational, which is a direct method, therefore definitely 6 plus root 2 is an irrational number. But to prove that by contradiction method, let us assume, please understand, let us assume that 6 plus root 2 is a rational number, then 6 plus root 2 is equal to a upon b, and by taking 6 to the right side, I get a by b minus 6, and we find that a minus 6, okay, a by b is a by b minus 6. 100% it is a rational number because all are integers here. So RHS is rational, whereas root 2 is irrational, and irrational becoming equal to rational is impossible. So this impossibility has arisen, or the contradiction has arisen because of our incorrect assumption that 6 plus root 2 is a rational number, whereas it is not. So the conclusion is that 6 plus root 2 is an irrational number. So these are a few examples to prove how as to whether that given number is rational or irrational. Very simple contradiction method, a logical method which you have to understand and remember. So try to learn these examples, because one of these will definitely be there for the examination. The method should be understood logically, contradiction method has to be understood and then written. So try to learn them, practice them and remember them. So note down in a book again for your future reference. Thank you.